Hello, grade 12s. Today we're going to be going on to the converse parallel line theorem. Okay, and we're going to be dealing with slides 37 to 39 from the PowerPoint's proportionality. Okay, so what the converse parallel line theorem says, if a line divides two sides of a triangle in the same proportion, then the line is parallel to the third side. Okay, so in other words, if this AP to PQ is equal to AQ to QC, then we know that this line must be parallel to that line. Then PQ must be parallel to BC. Okay, and the reason for this that we're going to use now is line divides two sides in proportion. Okay, that is the reason. So it's just basically the reverse of what we did before. Basically, we were saying if this is parallel to this, then we get these proportions coming out. This is just working the other way around. If we have these proportions equal, that must be parallel to that. Okay, so moving on to example 1. So example 1 is saying we have to prove that DF is parallel to XZ. So we have DF parallel to XZ. So what I'm going to do is I'm just going to jump ahead a little bit and try and see how we're going to do this. So if we have to prove that this is parallel to this, then I must show that this PD to DZ must be equal to PF to FZ. Okay, so that's what I'm looking at. And I'm just going to make a note of it here. Okay, so that's what I'm going to be looking at and trying to prove. Okay, so let's have a look at what we've got here. We've got a couple of parallel lines and what have you. So let me just highlight them so we can see what is going on here. And then we've got on this side over here. Okay, so first of all, I can see that using the blue lines, I can see that PD to DX will be PE to EY. Okay. Then what I can see with the green ones, I can see that PF to FZ would be PE to EY. So what I can do there is I can prove that those two proportions are the same because they're both in proportion to this and this. Therefore, that must be parallel to that. Okay, so let's write it down so you guys can see what's going on here. So PD to DX must be equal to PE to EY. Okay. And this is the blue one that I'm using here. Okay, the reason for this, line parallel one side triangle. And the parallel lines that I used were this DEXY. Okay, the next one I'm going to use is the green ones. I can see here that PF to FZ. So PF to FZ will be the PEEY. And this again is line parallel one side triangle. And then the parallel lines that I used were EF parallel YZ. Okay, and that was from the green ones. Now, as you guys can see, they are both equal to this PEEY. So therefore I can set these two equal to each other. So we get PD to DX is equal to PF to FZ. Okay, so now we have that this PD to DX is PF to FZ. Okay, maybe I should just put some little hops in there so you guys can see what's going on there. So that to that is equal to that to that. And because we have that, and I'm working in this triangle PXZ, these must now be parallel. Okay, so therefore, DF parallel to XZ. And my reason? Line divides two sides of the triangle in proportion. Okay, so that's example 1 done. Let's have a look at example 2. Okay, so for example 2, they're telling us that we have this PO is equal to OX. So PO is equal to OX, so this length is equal to this length. And then they've told us that BO is equal to OC, so this length is equal to that length. Okay, so question A. Question A is telling us prove that this BP CX is a parallelogram. So if I look within the shape here, we already know that this is equal to this and this is equal to this. So that's one of the properties of a parallelogram, that the diagonals bisect each other. So we know that PO equals OX and BO is equal to OC. That was given to us. Therefore, this BPCX is a palm. And the reason for that, diagonals of quad bisect. So diagonals of quad bisect. Okay, so that was an easy one. Then question B. Question B is asking us to prove that AZ to ZB is equal to AP to PX. So AZ to ZP, ZB is AP to PX. So how would I do that is by, if this line is parallel to this one, then we have that in proportion. Okay, but we already know which lines are parallel because we have a palm. We've just proved that. So basically this line over here will be parallel to that one. And this line will be parallel to that line. Okay, so now that makes it a little bit easier to see because we've got this AZ, ZB, AP, PX. So we can use our orange lines. Okay. So first of all, I just have to state that. I have to say that BX is parallel to PC. So BX is parallel to PC. Now I know I've gone over there. I'm going to explain that in a bit. So my reason for this is opposite sides of the palm. Okay. Therefore, BX is parallel to ZP, which is that little bit there. Okay. Then we can say, therefore, AZ to ZB, AZ to ZB is equal to this AP to PX. Okay, AP, PX. And the reason for that, line parallel one side triangle. Okay, question C. Question C is asking us to prove that ZY is parallel to BC. ZY parallel to BC. So how can I do that? Well, I can show, if I can show that this AZ to ZB is equal to AY to YC, then that must be parallel to that. So that's my aim, okay? So first of all, what I'm going to say is I'm going to say that AZ to ZB is equal to this AP PX. We proved that above here. Okay, so this to this is this to this. Okay, and if I can link that AP to PX to this side, then I've got it. But as you can see, I've already got it because these blue lines are parallel. So this AY to YC is AP to PX, but AP to PX is AZ to ZB. Therefore, those things must be equal, and that's my logic, okay? But before we jump that, I must just prove it. So the next thing we know is BY is parallel to XC. So this BY, XC, the blue ones, okay? And its opposite sides are palm. Okay, so from that, I can say that AY to YC must be equal to AP to PX. And the reason for that, line parallel one side triangle. Okay, therefore, because they are both equal, this here, they're both equal to that, therefore these two must be equal. Okay, so therefore we have AZ to ZB must be equal to this AY to YC. So we've proved that purple bit now. Therefore, because we've got those in proportion, ZY must be parallel to BC. My reason, line divides two sides, triangle in proportion. Okie dokes, guys, I would like you to do exercise 5 for me, please. Thank you.